Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Wi-Fi 6E. So let's dive right into it. Well, first we have to understand Wi-Fi 6. Now, Wi-Fi has a corporation, same way Bluetooth has a, USB has an association, Compact Flash has an association. Wi-Fi also has an association to it. Now, they decided something very interesting, something very awesome, that the standards will have a new naming convention. So, if you are familiar with Wi-Fi for a long enough time, you know the fact that they were named in really awesome ways like 802.11b, 802.11a, A.A02.11G, and for some reason A is the second one, B is the first one, so you get the point. Super awesome naming convention. So this time, like, nope, let's simplify the stuff. So simplification is happening. So 802.11G Wi-Fi equipments will be classified, not G, N equipments will be classified as Wi-Fi 4, AC equipment would be classified as Wi-Fi 5, and the latest one, AX, would be classified as Wi-Fi 6. So no more this AC, N, G, AX, all that hoo-ha out of the window. Simple, elegant naming convention. Super awesome. Now the reason for this is just not for the name change. The reality is the new standards were demanded out of a new time. Like, basically the amount of Wi-Fi devices went from few million to few billion. So reality is the demand on Wi-Fi system is much higher, and if the core protocol is not up to the task, it's gonna suck. So new times, new challenge. So new standards were created for current time requirement. Now the core focus on Wi-Fi. So if you are an individual who's like, I live alone, like I only have like me and all that jazz, you don't need this kind of technology. But the core focus is better multiple client management. What does that mean? That inherently means if you have multiple equipments, multiple users, so like let's say you have a wife, you have a mom, you have a dad, you have a kid, all of them are using Wi-Fi at this point in time. One router could not feed them, and heck, even if you have a very powerful router, problem was the protocol itself was the limiting factor. It inherently could not do it properly. So that was the bottleneck, so to say. So in Wi-Fi 6 they are removing all those bottlenecks and rebuilding the core protocol so it can handle multiple clients. So if you are living alone individually, it does not matter too much. It's not going to be like wow for you. But if you are in a scenario where you have multiple users, let's say office, a big home, or a shared apartment and all that jazz, is going to make a huge difference. So that's what we are talking about. So first we have to understand what were the problems that required this kind of a name change and huge technological change. Number of devices, that's obvious. Like, we went from one Wi-Fi device to multiple Wi-Fi devices per individual. Now single router has to manage it, because think of it this way, we were able to handle this to some extent in enterprise environment. This was a common thing. Like, you could have gone to a few years ago in Apple center headquarters and all that jazz, Wi-Fi would have worked for every equipment somehow, because it was possible to do that in enterprise grade equipments. But the reality was that's not everyday use. For everyday people, they just have one router that was generally given to them by their own service provider. For my case, I have a fiber connection, so the company provided me a Wi-Fi router combos. Every has like modem, router, switch, all that all in one. So that has to manage all this equipment. It inherently could not do that. So that's the main bottleneck they are trying to remove. Like, okay, this router, even if let's say you have a fat pipe coming to your home, this pipe is the choking point. What's the point? So base residential speed is now high. What does that mean? That inherently means even in India, for example, you can get fiber connection in around almost, if your state or city has a multiple airport, there is a very good chance you live nearby it. So you can get fiber connection, and in big cities you have like multiple fiber providers, so you can easily get 1 Gbps connection. It's not that much of big of a deal. Heck, even in my small town, I have access to internet provider that can go upwards of, like, this is my current connection, around 1500 rupees I pay for it, with I have to also add tax on that. That gives me 300 Mbps. So be mindful, I'm no longer in a position where my old connection would be enough. Basically old Ethernet standard of 100 Mbps, it's gonna exceed that. So flat out I have to have 1 Gbps Ethernet equipment, otherwise flat out I won't be able to use it. And data bandwidth was also upgraded. So data went from, like, I was getting 500 GB per month to 3.3 terabyte, and up and down is also there. So, and not to mention, I have 3 mobile phones continuously running in this household, and the 4th one will be added very soon. So reality is, lot of people, very big fat pipe, so we have to have a way of handling that. So reality is that equipment is the bottleneck and protocol is the limiting factor. So this was a needed upgrade. It was like, it's a bit behind schedule, but it was needed. And IoT devices needed special attention. Why is that matters? Think of this, when many IoT devices are security related things. Basically, your door alarms, your glass break alarms, and all that jazz, and door unlocking systems. So many of the time they were like, what should I do, what should I do, what should I do? So reality is that consumes battery, so they have to redesign a protocol in such a way that IoT devices consume less power, because if they don't consume less power, they have to use either very huge battery or they have to change battery regularly, which neither of them is acceptable. So these are the problem, these are the modern real world problem which Wi-Fi 6 tries to address. So how the heck it addresses? What is the solution? Well, reality is, if you truly want to understand it, you have to have thorough understanding of electromagnetic spectrum, spectrum analysis, band frequencies, and PhD of 1 or 2 PhD just for good sake. So it's a very complicated. So let's try to simplify it. Simplest sense: multiple input and multiple output. That's the core selling point. MIMOs. What does that mean? That, think of it this way: in Ethernet, you have multiple cables. The reason for that is it can send data on one, receive data on another. It's like, cool, I got this, I'm happy. Even in fiber, even if you can see one fiber, it will have like a red LED, basically red spectrum was used for sending data, blue was used for receiving data. It can be done with different spectrum and all that, but you get the point. You always want to have two independent systems. Our current Wi-Fi structures, or especially even a little bit old Wi-Fi architecture, is like, hello, what's up, you good? Okay, hello, what's up, you good? It's like, it's doing like this, step by step, step by step. It's very slow, inherently slow. So from that to, like, okay, one-to-one conversation is going to 8 conversations. So one router with a proper standardization and testing can easily, technically, should be able to handle 8 communication parallelly. So it could be like, okay, I got this, I got this, I got this, I got this, I got this. That's what it is. And 8 devices is more than good enough. At that point in time, like, what the hell you are doing? Even in normal family, what are you doing where you are exceeding that 8 devices? So that's the whole point. The main multiple devices, input and output at the same time. So it's basically, we are going from SATA to SAS equipment that are used for like server, where you can read and write to hard drive at the same time. So we are doing that on a protocol level. Then it has magical technology known as beamforming, basically aiming using phase shift. What does that mean? That simply means we are using the technology which was used in ICBM defense systems, military radar to 5G. We are using that 5G technology into our own home. So what you have is 4 antennas. Now 4 antennas have radio, basically they are sending the radio, but if you can time them right, you can literally have an antenna that is like this, but signal can go like this, or like this, or like this. You can basically aim the signal anywhere you want. So that's the reality. Beamforming will allow you to basically, that direction is the mobile phone, send the goddamn signal exactly that direction. It's not gonna send here or there. So you will have, like, if you take a signal strength meter, you're gonna like 80% until that device. If you go in left or right to that, it will like 20%. So awesome. Reduces interference, improves signal integrity, everything is awesome, and does not require too much new power. So super awesome. Wake IoT devices. I specified Internet of Things devices require battery run operations. They have to be very efficient with it. So it's achieving that by utilizing what we call, I'm going to tell you when to wake up. Now, condition applied, you have to buy new equipments that have Wi-Fi 6 certification, but that's the main aim for this. So use of that would be, let's say you come to your home, you have a smart door lock, your mobile phone automatically is going to detect that. It's like, bro, I'm close to home. It's going to send the signal through internet or through Wi-Fi itself. It's like, okay, it talks to your router. It's like, bro, wake up the system. So now the Wi-Fi router is going to talk to the IoT device and it's like, bro, wake up, unlock the door. Otherwise, the older system was like, every few seconds it was like, should I open, should I open, should I open, should I open, or something like that. So that change will allow IoT devices to be much more energy efficient. Awesome. And then wider band. Now, if you are familiar with the old Wi-Fi, you know we used to use 2.5 gigahertz. We still use it. It's a very backwards compatible, and many devices have that. So we went to 5 gigahertz, fatter pipe, and bigger chunks of channels were there in that spectrum. Benefit, more data you can send. This time we are making that even fatter. So we went from 40 megahertz channel to 80 megahertz channel to 160 megahertz channel. So at that point in time, each chunk of data that you can send is huge. Awesome. Coloring the signal. Now that is very odd way of saying that, but basically that BSS coloring, what does that mean? That simply means if you have multiple equipment, let's say multiple access point, multiple routers or things of that nature, they're gonna be like, whoa, this signal is not related to me, I'm not gonna interfere with it. It's like, bro, let the pass. Basically it's like, it makes them much more wiser, so to say. And time-based slot less packaging. This is the most advanced thing. But if you are familiar with CDMA network, we used to use the similar thing with the mobile phones, where they was like, okay, mobile tower is gonna be like, okay, I'm gonna take 1 second, slice it in, let's say 1000 units, and every 1000 mobile number that I have to keep out, all of them is gonna get that one slot. It's like, dude, talk to me in that slot. I'm not gonna listen to you other slot than that. Yes, it's a common technique used in even with optical fiber networks. You don't have a luxury of, like, you know, sending data to every single optical fiber link. So they will be like, okay, in this second, this unit, I'm going to talk to this user, another unit, I'm going to talk to this way. That way you can streamline everything and schedule everything. Now you may be thinking scheduling means slow down. No, because it's a fixed time system. You cannot, like, you can miss your packet, but other devices won't be affected by it. So let's say one device is acting up, it will simply be ignored. So that device will like, hey dude, I don't think I am on a network. Other devices like, we are cool, everything is working. So that way it reduces what we call packet loss. So if right now current architecture is like, everybody is yelling and router is trying to understand what the hell. So benefit of that is it does work, but problem is packet loss is too high, because two equipments could send signal at the exact same time, both will collide, both will cause interference, packet will be scrambled, router will receive it and it's like, bro, I can't understand, please can you send it again. Outcome would be that your speed would be halved if lucky. So reality is this time, like, dude, 1/600th of a second, send the data, 1/700th of a second, send the data, no interference. That's awesome. Basically streaming line thing, reducing packet interference, everything is awesome. And better security protocol, because again Wi-Fi, it has been hacked so thoroughly, like, it's a joke at this point. I'm like, this is how you hack a Wi-Fi network, because the core network was like very forgiving. It was like, just to maintain backwards compatibility, but this time it's like, bro, we will not give you that option. It's like, if you want to use this standard, you have to be in at least good enough level of security. You cannot use like, oh, very old networks. No, flat out no. So why I was making this video, Wi-Fi 6E. Now that 6E not supposed to happen. The Wi-Fi naming convention was very proper, but because of government bloat, government delayed their decision making. So FCC was like, FCC in USA was stuck. If they were not stuck, the 6 gigahertz bandwidth would have been opened up. And when that would have happened, they would have announced Wi-Fi 6 and naming convention would have made perfect sense. But because that part, that aspect was delayed, so they were like, let's release the 6. And once they release the 6 gigahertz bandwidth, they're like, okay, call it 6E extended. So reality is this band is active now. What does this mean? This band from 6 gigahertz to 7 gigahertz is classified for unlicensed use. What does that mean? That means you do not have to pay royalty. You do not have to do bidding war like how people do in 5 gigahertz band, or if you want to use satellite communication and all that, like there is a bidding war for that. Super expensive. You don't have to do that. Basically, this is like completely free. Government is like, only regulation here is like power consumption. You're not supposed to put like a transmitter that is like 100 gigawatts of power consumption. You can't do that, because you have to understand this 6 to 7 gigahertz has been used for multiple things, one of which is actually talking to satellite. So again, if you are in a local area and you are using very powerful antennas, you could disrupt the signal from there. So that's why if power level is low enough, it's like, I got this, everything is cool, no rules, no regulation. Power level is the main crucial aspect here. So the benefit of that would be less congestion, because we went from 2.5 gigahertz to 5 gigahertz. It was like, okay, less congestion. 5 now has the same thing. Every mobile phone now has 5. Every TV has 5 gigahertz. Every computer, every laptop has 5 gigahertz. So reality is we are back to the square one, where it's like everything is congested now and the number of devices are still growing. So we are like, okay, let's go to next bandwidth, 6 to 7 gigahertz. This time it's much less congested, at least for the upcoming few years. And this time the throughput theoretically is around 10 Gbps, but real world actual experience is around 1 Gbps. Now that is very critical. That is normal Ethernet standard for most computers. Some do have 2.5 gigahertz, some have 5 gigahertz, or very high end computers could have 10 gigabits per second. But this is very good. That means 100 megabytes per second. That's solid. That's solid chunk of data transfer from point A to point B. At that point in time, you can take a laptop and it's like, dude, I'm not gonna benefit too much from having an Ethernet system into this. And because of that time slot system, which is very latency proof, quote unquote, like it will have a fixed latency, it will not go YOLO fluctuating up and down. So it's very good. You no longer have a true reason for Ethernet. So again, it's theoretical, it's if it works and all that, but it has been achieved. People have achieved 1 Gbps on a mobile phone, on a laptop, things of that nature. So it's pretty awesome. However, Because higher the frequency, the lower the penetration, the outcome is the colder Goldilocks zone is around 7 meters. So you put a basically a Wi-Fi router on rooftop, 7 meter, like make a sphere of 7 meter radius. That's your awesome coverage. Everything other than that will be like either low connection or basically flat out disconnected. So reality is we are going away from congested space. We have an unlicensed new spectrum, completely like no rules and regulation, and we're gonna have fatter pipes, so each data packet would be wider. So everything is awesome with 6E, and 6E, many people are claiming that it is a much bigger deal than 6 itself, because 6 supposed to start with this, but again, government, bloat, hoo-ha, jingalala, so that things happen. So what can we expect in future? Well, reality is this sort of features were already available in enterprise equipment. That's how people like large corporations used to work. They had multiple access points. They had dedicated server equipments that were like just managing the handoff from one mobile device to another access point to another access point. There was like equipment specifically built for that, and this is a real thing. It used to work. It's just that it was super expensive. It was like, don't even think about it, like as minimum as like $5,000. Don't think below it. So reality is this sort of technology is already there. Now we are bringing it down to common consumer level, and latency, because of the time slicing, is like a fixed. It's no longer be like whoa, that will not happen. And multi-user support, this will be really useful for almost everyone unless you live alone. And in other scenarios, one thing side effect will happen is that our equipment is going to go ludicrously expensive. This is the cheapest Wi-Fi certified, so to say, Wi-Fi 6 router I could find that was 7,000 rupees. My old router was like 1,500 rupees. So surprisingly expensive equipment. And Wi-Fi 6E, Asus just released a new god tier level router on that. God damn it, the pricing on this puppy is painful to watch. It's like $300 or something like that. So very expensive equipment. So Wi-Fi will no longer just buy a Wi-Fi. Like you have to sit down and plan for it, calculate the pricing, and then buy it. So that will be one price that we have to pay. But if you have multiple people using your network, this would be a worthy upgrade, so to say. So this was my presentation on Wi-Fi 6E. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me your disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.